Okay. So it's time to start the meeting between the NLA and the international advisors. I'm Toyoshi Fuketo, chairman of the NLA, and I would like to say thank you very much for joining us. Tonight for us, it's at 8 p.m. in Japan, and at 11 o'clock or at noon in the European countries. And I'm sorry for Mr. Miserve, it's just 6 o'clock in the morning, very early morning. So thank you, in particular, Mr. Miserve, to join this meeting. So I prefer to have a meeting face-to-face, but of course it's due to the pandemic. We could not have a meeting face-to-face. So we are going to have a meeting virtually, and also today we have a meeting for only 90 minutes. So we concentrate on the two subjects in this meeting. One is regarding the design permit. Well, we call in the written material, it is in business permit, but actually it is a design permit or design certification for the reprocessing plant. And this will be explained by Commissioner Tanaka, and we would like to hear about your views and opinions or comments on our permission on the reprocessing plant. And the second topic is, as you already know well about our new process, we introduced the ROP, Reactor Oversight Process, from the United States, and we are in the very beginning stage of the operation of the oversight process. So Commissioner Yamanaka will give you an overview of our early challenges in the oversight process. And again, we would like to hear your views and opinions on our challenge regarding the inspection processes. So let me give the mic to Commissioner Tanaka to start explaining the situation and the results of our permit on the Rokasho reprocessing plant. So please, Commissioner Tanaka.
Thank you very much. Good morning and good afternoon. Okay, it's very nice to meet you again and online. At the beginning, I'd like to explain the history of JNFL reprocessing plant. Maybe it is also sent to you by email. Okay, the construction started in 1993 and started receiving spent fuels in 1999. At present, about 3,000 tons of spent fuels are stored in the pool, almost full of the capacity. Okay. Also, uranium test started in 2004, and active test started in 2006. However, some pre-service inspection, such as for vitrification, has not yet finished. Okay. After Fukushima Daiichi nuclear power plant accident, new regulatory requirements were added to nuclear fuel cycle facilities, including reprocessing plant. In July this year, NRA permitted the amendment of business permit for reprocessing plant facility. As next steps, before the operation of plant, JNFL had to get the approval of design and construction plan by the NRA and the confirmation of licensees pre-service inspection by the NRA. It's a very big challenge also to the JNFL. In the new regulations, several regulatory requirements are added to design basis facilities, and requirements for severe accident are new. Some points during conformity review are described in the paper we sent to you before, and also in the attached PowerPoint slides for more detail. Now I'd like to explain some of them. First one, maybe it is the PowerPoint page 7. First one is the changing of spent fuel cooling period. it was changed from more than 4 years before sharing to more than 15 years before sharing. By this change, activity of Lutetium-106 decreases so much. Its half-life is about 1 year, and it's a key nuclide at the severe accident of evaporation to dryness, because by high temperature, the chemical form of Lutetium changes, and it, the big release. Okay. Also, next, maybe the page 12. It's the evaluation of external fire caused by airplane crash, because that the nuclear replacement plant is very close to the U.S. bases, and also the many airplanes flying over there. So the evaluation of external fire caused by airplane crash is important. Licensees assumed fire breaks out on exterior wall of the building. The NRA judged that the safety function of buildings and the safety function of equipment inside the building are not impaired. Next important thing is the prevention of damage caused by airplane crash, the page 13. So the airplane crash probability is evaluated for each process area basis. It means not all of the building. For each process area building, the NRA confirmed that additional protective measure is not necessary because the crash probability does not exceed the criteria of 10 to the minus 7 times per year for each process unit. For severe accidents, 6 accidents were considered, as shown in the page 14 of PowerPoint slide. In page 15 of PowerPoint, amount of radioactive material released in the event of severe accident are shown. The NRA confirmed that the amount of radioactive material released for each accident and the amount released when severe accident occur simultaneously are less than 100 terabecquerel cesium-137 equivalent and as low as possible. At criticality accident, at page 16, neutron absorber is automatically supplied immediately after criticality is detected. Also, increasing of hydrogen exhaust. Radioactive materials are automatically transferred to waste gas storage tank. So it means the release to the environment is become very small. And also about the severe accident of dryness, evaporation to dryness accident, page 17. There are many types of injecting water, such as inject water to the internal loop, inject water directly to the vessel by alternative cooling system, and inject water to cooling coils. For mitigation measures, guide radioactive material to another cell and decrease discharge by alternative cell exhaust system. Okay. Also, now I'd like to say about the next steps. As I said, before plant operation, the NFL had to get the approval of design and construction plan and the confirmation of licensees pre-service inspection by the NRA. This will be a big and important job also to us because there are many equipment, more than 10,000 to be considered. So in June this year, the NRA showed the procedure for reviewing and confirmation. Some of the important points which we showed are licensees should clarify the facility for design and construction, should show the QMS policy and should show the policy of licensed pre-service inspection, including facility already inspected. As basic policy for reviewing design and construction plan, we showed non-overlapping of review because there are equipment which have same function. To review, considering the importance of system and equipment, and to review the representative ones after categorizing and grouping the system and equipment. So this is a point we showed in June this year. Last week, we had an exchange of views meeting with the president of JNFL, Mr. Masuda. Design the construction plan and licensed pre-service inspection was one of the key points for discussion last week. Okay, these are the simple explanation of business permit and the next steps from the plant side. We'd like to have your comments and advice about these. And also, I'd like to ask the Commissioner Ishiwatari to add some words about for earthquake and volcanic activities. Please.
Yeah, good morning and good evening, everyone. Well, I'd like to provide you some information about the natural hazard of the Rokkasho JNFL site. Please see page 8. First, I have to tell you that there is a big merit of this site because, the important facilities of the JNFL Rokkasho site that you find right-hand side of the map that you see in page 8. This site is situated on the top of the hill, about 50 meters high. So no tsunamis can reach that altitude, and there is no danger of tsunami on this site. However, the demerit of this site is that there is a capable fault only at 3-kilometer distance from the Rokkasho site. You can see a red line along the seashore. This is the capable fault called Deto Seiho fault. And we have to evaluate the length and the attitudes of this fault by the geological survey. And the licensee in the initial amendment application in 2014 estimated the length of this fault to be 10 kilometers. However, in the re-evaluation indicated by our staffs, they made additional survey of this fault and find that the fault is a little bit longer, and they finally evaluated it as 11 kilometers. The nearest point is the southern end of this fault. That is the right-hand side of the fault is only 3 kilometers from the Rokkasho site. And the design basis ground motion that is calculated from the properties of this fault is about 0.7 g. The g is a gravitational acceleration. So this is the most hazardous seismic source for the Rokkasho site. And please see the next page, page 9. You can see a spectrum of the expected ground movement by the Rokkasho, Deto Seiho fault and other faults. And you can see the 700 gal or 0.7 G at the 0.02 second period, that the left-hand end of each spectrum. And another hazard that should be considered is volcanic activity. Please see the next page, page 10. This Rokkasho site is near to the big volcanoes such as Hakoda and Towada that is indicated on the map. And in the Rokkasho site, the licensee have found the outcrops of volcanic ash and pyroclastic flow that was emitted from these two volcanoes. So the licensee should prepare for the weight and the weight of the volcanic ash that should be deposited on the site when the volcano erupts. And the thickness of the expected volcanic ash should be finally about 55 centimeter. And as the licensee also found the trace of the pyroclastic flows that have emitted from Towada volcano in the Rokkasho site, the licensee should make every year. They should make monitoring of the volcano, such as geological, geophysical, and the thermal observation. So that's the outline of the natural hazard that is expected for the Rokkasho site. Thank you.
Thank you, Commissioners Tanaka and Commissioner Ishiwatari. So let me add a few words on these topics. Well, the NRA gave a so-called design license to JNFL regarding their facilities and also their variation for external hazards. But the JNFL still needs to go through another licensing process for the details in design and construction. And also they need to get approval regarding the first-hand inspection process. So they still have at least 2 years. Well, JNFL declared that they would like to finish all these processes within 2 years, but it looks a bit challenging. So we still have lots of things to do before the start of the commercial operation. And during the design, the licensing process for the design facilities of the design of facilities, one of the well, in my view, one of the most difficult thing is how to define the severe accident in reprocessing plant and how to design the countermeasures against severe accident. So please, now we would like to hear your questions, views, opinions, or comments. Please raise your hand that we can. Please, Mr. Mizo.
Thank you very much. I really appreciate the obvious and very large work that you have done in preparing for this site and dealing with this site. It's very impressive how comprehensive the work is. It's very clear you've thought very deeply about the challenges presented by this site, and it's very impressive. I have one question that is puzzled me, that isn't completely clear from your slides, and it relates to one of the lessons from the Fukushima accident, in that one of the very difficult challenges we've confronted is trying to deal with the PRA issues resulting from the fact that an accident at one unit impacted other units, and that wasn't part of the analytical technique. As you've described this, that each of the processing steps at the Rokasho plant is isolated from each other, and similarly, you're going to have a MOX facility that is co-located as well, that is also going to be licensed. And I'm curious as to whether you have had to evaluate the impacts of a problem or an accident at one portion of the site with the separate processing steps. So you seem to have looked at them sort of one, obviously external events can affect all of them, but that, you know, if you had an internal event at one part of the processing plant, it could have consequential impacts on the other one, that, like the Fukushima site, where you didn't have, there wasn't, no one in the world was thinking about the impacts of a problem at one unit on other units. And the same issue seems to me could arise at Rokasho.
Well, you're right. One of the most specific things in the reprocessing plant is there are a variety of consecutive processes in the reprocessing plant, and also, as you said, they have a MOX facility in the same site. So during the licensing process, we have checked the effect of the postulated accident in one process to the neighboring processes. But, well, how can I describe the details about the, but for example, about the internal fire, we need to have a mitigation of the fire events in one process, and how much of the impact of the internal fire to the next process. But I really do not have the detailed materials about how we can estimate the so-called accident propagation. Can you?
I worked on the safety review of the Jennifer plant, but I don't think I have a good explanation better than the Commissioner Fuketa. But as he said, what we done was that even though the Rokasho reprocessing site consists of various processes, but we have checked all individual process can be is completed by themselves, by itself. So one process will not affect on the process, even in case of severe accident. So then we confirm that the safety function, safety measures is maintained for all processes. If it helps you, I hope.
Andy or Philip, do you have any experience about the accident propagation in your reprocessing plant?
Frankly speaking, I don't know about this point, but I have questions for you on other subjects.
Well, before this licensing review, we have checked the experiences in France and in UK, but we only had limited information regarding how to define the severe accident at reprocessing plant, and also particularly the severe accident propagations through the different processes. Andy, sorry.
Thank you. Been a very interesting presentation, so thank you for that. In terms of the UK experience and interaction between plant on a site such as Sellafield, what we have required the licensees to do in the past is not only develop individual safety cases for the individual facilities, but also a site-wide safety case as well, which should take into account any interactions between them. And of course, on a large complex site like Sellafield, there are very many interactions, pipe bridges and other communications and common supply services. So that should have been taken into account in the site-wide case, although I don't have familiarity with the details of that, so I can't really say very much more than that.
So you mean the site? I'm sorry. So you mean the site-wise safety case is not just a compilation of the individual facility safety case?
Yes, that's correct.
And Philip and Dana, please.
Yes. Okay, I not well understood what you said before. The principle is the same in France, and this was set up in the follow-up of the Fukushima accident. So for all big sites, whether they are CEA sites or Orano or Areva sites, it is required that if there is a big problem in one of the units, it should be studied whether this could propagate in others. Okay. Now, about the severe accident, first, it's not for some reason it's not called severe accident for reprocessing plant in France. It's called redoutable accident. I don't know how to translate it in English. It's determined building by building, okay? And for example, this evaporation of and dryness due to loss of cooling function is typically one of them, of course. And then there are others where we had some problems with some leakage of some tanks with high radioactive liquids, and this was also one that was considered. May I ask a question myself? From your presentation, I understand that for the airplane crash, you have two approaches. One is to consider the fire that is due to an airplane crash, and then you check whether there is any safety issue associated with this. And then I understand that you also have the direct effect of the impact of the airplane on the buildings. I understand for the impact of the plane on the buildings, you're only considering military airplane and no, or at least for the direct impact. When I read your presentation, this was my feeling. So can you be a bit more specific on what type of plane you consider for both effects, fire and direct impact? Thank you very much.
First of all, we had extensive discussions regarding the probability of the airplane crash, and then we defined the assumption regarding the largest size of the plane to crash on the site, on the building. And then, well, some of them are excluded during due to the probabilistic considerations. And fire effect is, it's a divided discussion. Fire caused by airplane crash is separately discussed on the impact on the facility. Well,
okay, so about the kind of airplane, we consider that all airplanes had a possibility to flying in these areas. Okay, not limited to the airplane from the bases. Okay. Also, the as the chairman said, the fire by airplane crash and directly to give some damage to their building, it's a different one. So for the building, we evaluate the possibility. So the possibility is less than 10 to the minus 7. Our standard is not necessary to make additional guarding system for the building. Okay. And also by the firing. So the important thing is which is the fireplace. Okay. So the guide was made for nuclear power plant. The nuclear power plant is not so difficult to decide the spot of firing by the probability 10 to the minus 7. So the building, so it's very easy to find the point. But for the reference plant, there are many, many buildings. So just translate the guide from the nuclear power plant to the reference plant is not so easy. So we consider so much. So we decided to make the fire very close to the building for the external fire by air crash. This is our point, and also it is our method for evaluating.
Philip, would you like to have an explanation about the airplane crash, probability consideration of the airplane crash? I'm asking
No. Well, to be completely straightforward, you can talk about probability of airplane crash if you're talking about accidental airplane crash, but if you're considering security problems, probabilistic evaluation is much more, less obvious. So, I was, at least in France, we treat accidental airplane crash to a certain extent differently from a terrorist attack. Because it's very difficult to evaluate the probability of a large airplane crash that is voluntarily done on an installation. So the two parts are differentiated. And for security, frankly speaking, it's if I take an installation like the French reprocessing plant, the only way is prevention, because we cannot say that all the buildings are strong enough to stand a major airplane crash at full speed.
Yes, it is a little complicated, but very important discussion on Rokkasho reprocessing plant. In particular, the plant located in the vicinity, not in the vicinity, but not far from the military base, Air Force base of U.S. Air Force and Japan's defense forces. So all the buildings are designed intact against the airplane crash, but we need to assume the how much of the size, how much of how big the airplane will crash onto the building. And one example is JNFL designed the buildings intact against the airplane of the F-16. Are you familiar with that? It's not the largest, but the F-16 Air Force airplane. And when we discuss about the larger size of the airplane, for example, A380, which is the largest airplane in the world right now, it's a French airplane, by the way. But we didn't think about such airplane because the A380 are not flying in the vicinity of the JNFL plant. And also we have in this stage, we have a probability considerations regarding the airplane larger than F-16. Does that make sense?
It sounds logical, yes. I mean,
well,
but again, I think it's. I'm still. I think this is a problem for all of us. But treating voluntary airplane crash in terms of probabilistic, approach is not so obvious. This is all I want to say.
It's different in the different stage of the accident. I mean, the what kind of the airplane crash is defined as a design basis accident or severe accident or accidents beyond even the severe accidents. So we have the several stages of the discussions regarding airplane crash. So, Dana, thank you for waiting.
Thank you very much. First of all, I would like to appreciate the presentation from the point of view of technical details that are in the presentation of the design of a facility. I try to concentrate myself on the possible impact of the release from the facility during the severe accident. First of all, I would like to appreciate the decision to change the cooling period before reprocessing of fuel, because it makes really the possible source term considerably more favorable for the vicinity of our facility. The second thing I would like to say is that the source term assessment shows that really the possible source term and during the severe accident is quite low. That means I believe that all steps to make it as low as reasonably achievable were taken. And then my little question concerning the vicinity of the facility and the population in the vicinity. I do apologize for my ignorance, but could you give me some details about the population density or bigger cities near the facility?
Well, thank you. First of all, you're right. The longer cooling period of the spent fuel has a big impact on the accident estimations. So it's a how can I say? It's kind of the benefit to estimate the source term in the possible accident. And your question regarding populations, well, it locates quite rural area, but sorry, we do not have an exact number of the population in that area. But it's in the northern edge of the main island of Japan, and quite rural and
industrial area.
It's industrial area.
Like the base of the oil.
You
So it's a design. So industrial design, like the apartment, the complex, like including some oil, the oil base, and some other stock yards. And other the industrial, not human concentrate area as an industrial facility. So very rural, basically, and even the facilities around them are very kind of machinery-based industrial.
Thank you very much.
Andy, thank you for waiting.
I've got a few questions on the presentation. Interested to see the way that the considerations that have been brought in for the nuclear power plants are now being brought in for other nuclear facilities as well. First of all, on the design basis ground motion, you talked about the re-evaluation of the length of the capable fault, and it's increased, I think, by about 10%. I wondered, though, whether that had any effect on the design or operations as a result, or whether you already had sufficient margins that has been accommodated.
Well, okay, I will answer for that question. I'm Ishiwatari, and for calculation of the ground motion, we do not take the length of the fault on the land floor, land surface. We estimate the underground length of the fault so as to match the expected magnitude of the earthquake. So in this case, the length should be about 29 kilometer, far much longer than the trace of the fault on the ground. And the fault of that length should produce the earthquake of about magnitude, moment magnitude 6.5. So, the only 1 kilometer of the increase of the length of the fault on the surface, actually it doesn't affect the size of the earthquake that should be produced by that fault. But anyway, we have to know the exact trace and the length and attitude of the fault as a scientific base. So that's we have to check it. Is it all right?
You. Yes, thank you. If I could just follow up with a couple more questions on volcanic activity this time. You've said that the probabilities of eruptions during the operational lifetime of the reprocessing facility were small enough. Do you have a numerical criterion for small enough? What does small enough mean?
Well, yes, we calculate the probability of the earthquake that should happen. That should be greater than the ground basis, design basis earthquake, but that is about -7 or -6, -6 about. But I don't remember well about the exact number, but the order of the -6 or -5, 6 about that, I think.
Right, okay. I think that's what I would have expected, so thank you for that. I've also got a question on the aircraft crash. Two aspects of that. One is you talk about the effect of a fire on the outside of the building, but I didn't notice how long the fire is expected to continue, because clearly the challenge to the building is going to depend on how long a high temperature is applied to the outside of the building.
The question is how long is the fire? So they essentially calculated depending on the guide. Maybe you know.
Well, we do not have the exact number
Okay.
at this time, but I think it's several hours at the high temperature.
Right. Okay. Because again, as Philippe was saying, the way that you treat accidental crashes is different from the way that you treat security incidents. But one of the things I know from the past is that in talking about the length of fires, consideration has been given to the amount of fuel on planes and so forth. So that gives you an idea of how long the challenge may last. Finally, my final question again on aircraft crashes, that for the accidental crashes, you talked a bit about the probability, and you said you could perhaps say a little more on that. And I'd be interested to know to what extent the probability is affected by proximity to airports, the orientation of the site in relation to runways, and whether also you take account of not only direct impacts of aircraft, but aircraft that might crash on the ground and then slide some distance before impacting a building.
Okay. Is it? なんか聞かれてはいないよね、別にね。Okay. Any other questions or comments?
And that is it.
Philip?
I understand this is a design review, but remembering what happened in Fukushima Daiichi, one problem was also the training of the teams in case of a very severe accident. So I understand it's probably not the right place to require something from the utility. But my question is, are you going to require somehow training and drills performed in case of severe accidents?
Yes, we have different procedures to check their ability and also their preparation and plan against the post-rated accident. And well, this is also quite difficult to define the intensity or severity of the accident we are going to post-rate. But in the different regulatory process, we will check their preparation of the documents or and also their plan for drill, and also our inspector will join their drill and just to check whether their ability is sufficient against a post-rated accident. Okay, now we have 40 minutes to go. So if it is okay, we would like to turn into the next topics. Is it okay for you? Okay, so let me ask Commissioner Yamanaka to explain about our challenge regarding the reactor oversight process.
So thank you, Mr. Chairman. Good morning and good afternoon. Thank you very much for attending the advisory meeting. So I would like to introduce the second topic, implementation status of new oversight program. So you can find some information about this topic in the handout for topic 2. So first, I would like to show you the timeline of our oversight program. So responding to the suggestion and recommendation of IRRS by IAEA in 2016, NRA has improved some of our activities. So NRA has been working to introduce new inspection system and amending the Reactor Regulation Act in 2017. So we have performed the regulatory reform of inspection framework in NRA, quite similar to Reactor Oversight Program, ROP, in the United States. So NRC in the United States has strongly supported this improvement in NRA. So aiming at starting the new oversight program in 2020, NRA have prepared program guidelines and inspection manuals and ensured inspectors' competence through trial operation. The trial operation started October 2018 and continued until the enactment of new law in 2020s. The licensees also participate in this trial operation for elaborations of inspection guidelines. So next, I'd like to talk about the important element and outcomes of new oversight programs in NRA. The inspection framework can lead to continuous improvement of safety. So this means clarification of licensee's primary responsibility for safety. The new oversight program is a risk-informed and performance-based approach. The comprehensive regulatory oversight and assessment system takes actions based on the results of assessment, but does not check every details of predetermined items. So NRA inspectors can comprehend as-is situations of plants by freely accessing sites anytime without escort and observe licensees' operational safety activities. So NRA inspectors can conduct inspections in a flexible manner, taking into consideration the status of plants and licensees' operational safety activities. Thus focus on matters of safety significance. So licensees considerably improved the CAP, Corrective Action Program, and started operating. The actual operation of new oversight program have just started from this April. So several good practices for our program have been already provided from start for half a year. So in spite of the COVID-19 pandemic situation in Japan, I think generally setup of the new oversight program succeeded. We would like to continue challenging the improvement of new oversight program after now. We would like to enhance training and qualification programs for inspectors. So we have to improve the risk-informed inspection through PLA and mature SDP processes, including nuclear fuel cycle facilities. So it is also necessary for us to continue the dialogue with licensees and with inhabitants about the new oversight program. So this evening, I would like to have your suggestions and recommendations for improvement of our new oversight programs. Thank you very much.
Thank you, Commissioner Yamanaka. So, any questions, any comments, please? Mr. Miserve?
Let me say that of course, I know that you've been implementing something that's quite like the program in the United States, the Reactor Oversight Program. And we have found this to be a hugely beneficial approach because intention is to assure that the attention is given to the safety significant issues. That you look at the risk of events and use that to guide things into focus. And that has enabled, I think, enormous improvement in the integrity of the inspection program, the value of it. So I think that this is a really a very, very important program, and I'm pleased to see your success in getting it launched. I have one I'm sure we're going to get some questions about the results of the oversight program. I've had an interaction with Philippe about one of them, and I'll leave him to talk about the slide as to the findings, which is a question. I have worried about. I know you're in a transition phase. That you're in a phase where you're building up the capacity to do the program, and it's hard to have a full-blown program right from the beginning, given it's so comprehensive. One of the essential ingredients of a program is to assure that you have a significance determination process, that where you have a finding, that you have the capacity to be able to evaluate it, to determine the risk significance of the finding, and then to use that to guide your further actions and what things you might require of the licensee and with their necessity for sanctions or further inspections. You have the challenge in Japan right now, as you're very well aware, of building up your capacity to do the risk evaluations. That the capacity to do PRAs is now probabilistic risk assessments is something that's being developed, and so the tools that you will eventually have to assess risk significance are not fully developed yet. And that is the core, of course, of the ROP, is to be able to assess risk. And I'm wondering how you're bridging the circumstance where you don't have full PRA capabilities to be able to assess the risk so that you can execute the significance determination process.
Well, before answering your questions, let me explain about one of the most important difference between the U.S. ROP and our oversight process. The risk analysis model to be used, SDP, in U.S. case, the NRC has an independent model and perform their own PRA. And the industry has a different model. But in our case, due to the very limited capacity and very limited experience in both sides, and so due to the situation we made a decision to use the industry's model. And we received the industry model after the independent evaluation of the adequacy of their model. So in our SDP, one of the difference between U.S. and Japan is that the NRA used the industry model under the agreement between industries and the NRA. And SDP, we have still quite limited experience because we only have 7 months experience in the new system. And we agreed we means that not only the regulatory body but also the industry have we face lots of challenges regarding to build the capacity of the PRA implementation. So do you have anything to add there?
Well, the reason I asked the question is because I know that the industry is also building up its capability on PRAs now, and that there has been very significant work they're doing, but it's also only now underway. So the scope, comprehensiveness, accuracy of the PRAs is not what it will be in a year or two.
I think there's pros and cons when we use the industry's model for our evaluation. Well, the evaluation itself is quite independent. We are going to make our independent evaluation, and the industry licensee will make an independent evaluation. But in the case of the United States, well, due to the industries and NRC use the different models, they always have a kind of controversy or discussions regarding for example, industry argued that NRC's model is too old or those kind. Well, so I think there is a pros and cons, the good side and bad side to use the same model between the NRA and the industry. So anyway, we are in the beginning stage of this exercise, and we'll keep discussing about how to build our capability and capacity of the PRA.
I think it is appropriate for you, under the circumstances, to be pointing to the industry's PRAs. Obviously, however, you need to have the capacity to examine them closely to make sure you're comfortable with their validity and that they cover what needs to be covered. But I'm not disputing the fact that you might take a different course than the U.S. in terms of whether the regulator should have entirely independent PRAs. I think that may be too much right now. And I'm not questioning the strategy that you have underway. I think it's a wise and appropriate way for you to proceed.
Thank you. Philip, please.
Yes, first, I'm very happy, and I was also very happy last year when I saw the progress of the inspection global framework and effort done by NRA on inspection. I think these were the main conclusions, according to my view, of the RRS mission, and I'm very proud that Japanese has changed the regulatory framework and that you're doing a lot of effort on this. So this is my first point. On the other hand, one comment about PRA. I'm fully supporting PRA. You know, sometimes it was said that French don't like it, but I'm fully supporting PRA. And I think that in many countries, many safety improvements were due to PRA. So, and they are also a very useful tool to, see what's important, what's not. The only thing is that when thinking about field inspectors, PRA is one tool. But I think if you take an inspector that knows very well the operational experience feedback and even knows very well the different accidental scenario that you have in deterministic approaches, he knows that when something is wrong and this might, for example, prevent the safety injection from working, or in case of an earthquake, everything would fall down, he could be also a good inspector. So it's very good to develop PRA, and I fully support it. But you have to keep in mind that from an inspection point of view, I think this is a very useful tool, but this is not the only tool. Okay, this was my comment. So don't completely assimilate the tool and the capability of inspection. Now, coming to one of my reflection on your presentation, I feel I don't understand what non-prescriptive inspection means. I mean, for me, an inspector has a framework, requirements, or knowledge or whatever, and the structure is supposed to find findings or identify gaps between the regulation and what happened or risks, and the regulator is supposed to require corrective actions. For me, very simply, this is my understanding of what is basically an inspection. And therefore, I cannot associate non-prescriptive and inspection. I can understand that there are interactions between utility and regulator, which are not leading to requirement, to understand each other better, to understand what are the plans, what are the scope, and so on. We did it very often in France. I know in Japan it was more difficult in the past. I don't know how it is now. But I can understand there are contacts between utility and regulators which are a bit, outside of the inspection process. But I don't understand that there can be a non-prescriptive inspection.
So I completely agree with Jame-san. The competence of inspectors is quite important for new oversight programs. I think so.
Well, I think there's a little bit it depends on the understanding of the word of the non-prescriptive. I think the Commissioner Yamanaka prepared this presentation. It means it's more flexible, or not rely on the checklist type inspection as we had before. So. But non-prescriptive is a kind of word for our inspectors. Should be quite flexible, and during the walk down in the facilities, well, they have a sort of the guide or prescriptive. It's hard to pronounce this, but prescriptive guidelines. Of course, they have sort of the outline of the how to perform the walk down inspection or such kind. But this is kind of the mind of the we should not be too prescriptive. I mean, everything was written in somewhere. So we would like to avoid such sort of the attitude when we perform the inspection. Still, it doesn't make sense? Philip, please.
No, I can understand that you don't want inspectors to be tough on details or on very formal things. But you should expect the inspectors to be tough on certain things.
Sure.
And there it should be, I hope, as a representative of the public and thinking about the regulator as protecting me, that he should be very tough.
Yeah.
Of course, he has to be able to decide that it's worthwhile to be tough. In other words, that the risk or the implications are important enough. And from that point of view, I also understand that you need training from education training from the inspectors, and that PRA is one of the possible tools. But the inspectors can be flexible on details, but they have to be very tough on the core risk problems.
Yes, it depends on the balance between the capability or ability of each inspector and how much we need to prepare the written materials to guide the behavior or everyday's work of the inspectors. So non-prescriptive inspection, you're right, it requires the high level of the knowledge and experience and the capability of the inspectors. So we need to think about quite carefully about how much we should prepare as a written documents or guidelines for inspectors, and also how much we can rely on each individual's own decision or own observation. So I think I understand what you're talking about, but it's highly related on the capability of each individuals and the capability of the inspectors. So of course we should make best efforts to educate the inspectors, and we need to prepare the education program on the inspectors, and also on the job training process. And in terms of the risk, I fully agree with Mr. Jame. Well, I also fully support the PRA, but the PRA is not only the tool, and we are going to keep performing the approach of the deterministic approach as well as the probabilistic approach. And the balance between those approaches are, well, always we are discussing about what is the good balance between the deterministic and the probabilistic. So, but anyway, I fully agree with your views. Thank you. Please, Andy.
Thank you. I fully agree with Philippe as well that the UK has what we describe as a non-prescriptive regulatory system, but nonetheless, inspections have to be structured, they have to be systematic. The standards that are being applied have to be clear both to the regulator and to the licensee. On the other hand, when you're performing an inspection, although you will go in with a particular plan in mind, it's also important to be able to respond to what you find. So I can see that in that case, it is important to be flexible. You don't simply go ahead with your original plan if during the course of an inspection you come across findings that suggest there are other avenues that you should explore. Thanks.
Thank you. Well, it's quite important suggestion, I think. Yeah. Any other? Dana, please.
Thank you very much. Two remarks, or better to say, one remark and one question for clarification. A remark concerning PRA. I almost fully support what my distinguished colleagues said a few minutes ago concerning importance of PRA. We use it in our regulatory practice in a very similar way, but we try to train our inspectors to feel that the PRA is a tool really according to its name. That means it helps to concentrate on a real important, if you want to say risky or possibly risky areas, and for our inspectors it is a tool to better understand the possible big points in the utility or in facility. That means our regulatory approach is based on deterministic analysis, using as much as reasonably achievable the risk insight to understand the possible big points with high significance. That was my remark, and maybe a small question concerning findings. My feeling is that what concerns those three findings mentioned in your presentation, all of them are in a category that in our case will be mandatory for licensee to actively communicate with nuclear regulatory authority without an inspection, if you understand me. That means that there is, in my opinion, need for active duty of a licensee to report such cases or occurrences actively, independently of any inspection.
let me clarify your questions. Are you asking are you talking about these three findings? Would be those be found by the licensees by themselves?
And actively reported to the regulatory authority, in my opinion.
でなんて答え
Maybe Philip can help me.
If I may, at least the two first ones, Onagawa Unit 2 and Mihama Unit 3, they are, for me, typically safety-related or safety significant events. And I don't know, but normally you have a system that constrain the operator to report and declare such events to the regulator. So to me, the third one, I don't know because I don't know enough the detail, but two first one, you should have been aware of those things by declaration of the utility. Then, of course, you can make an inspection to check what is really the severity of the accident, what was the reaction of the utility, what kind of correcting actions they want to check whether it's enough or not. But I don't understand that those two first points are findings. They are not findings. You should have been aware of it. They should have been declared.
This is exactly what I had in mind. Thank you very much, Philip.
Let me say, I think there may be a language problem. There may be a language problem here in that these are three events that, as Philippe has indicated, most systems would be reported and then result in inspections. I would have thought out of the inspection program, then would come findings, and the findings would be you have a problem in training, you have a problem in operations, you have a problem in engineering, that the findings would be directed at some aspect of the performance of the licensee that need to be addressed or corrected. These are events that cause you to go in and to do an inspection and to make findings as to what is the root cause of the event and what needs to be fixed so it doesn't recur. So I think there's somewhat of a language problem here as to what's an event and what's a finding.
Yeah, well, let me try to explain. The first one, the incident in Onagawa Unit 2, which is reported by licensee to the NLA. And Mihama Unit 3, in the case of the Mihama Unit 3 and the case of the Fukushima Daiichi, they are not the incidents should be a report to the regulatory body. It's not the mandatory to report to the regulatory body. So our inspector checked the documents of the licensees, and they already knew that those incidents as how can I say those two incidents were already listed as in the collective action program. So our inspector read it and found these incidents, and this is a sort of the how can I say incident should be estimated, should be evaluated by the regulatory body. So these three are not just findings, because the licenses, all these three licenses already knew about these things, and they already have their own collective action program. But the difference is, our view, we should estimate the severity or significance of these events. So they are listed, but not just I don't know that the word of the findings are appropriate to describe these stuff, I think. Philip?
I think what you said clarifies a lot. While we were speaking about inspectors and PRA and training and so on, I had a memory in mind from what ASN was doing. When they were, maybe you could talk with them, by the way, about this, but we were assessing the operational experience feedback every year. And for example, one of the things that we could see through PRA is the importance of certain equipment or the importance of certain maintenance operation and so on. And then as the sort of main, themes for the following year inspection, we were directing the inspectors to say, please look at this because we see that there is a bad trend or a safety trend concerning these procedures of this equipment. What was very useful is that we were explaining as much as possible to the inspectors how we came to such a result, because I'm sure that, I don't know, I don't have the statistics, but I'm sure at the ASN, not so many inspectors are really aware of PSA, how do you make it, the trees, the probability, and so on. But on the other hand, if you explain to them, when we do PRA, we see that this equipment is very critical for many accidental sequences, then he understands the philosophy of the whole thing. And then I think that from an educational point of view, this can be a little piece, but this can be useful for the guy who is really on the field inspecting a plant. I don't know how relevant it is for you, but this was a sort of contribution, let's put it this way.
Yes, exactly. I agree with you. Thank you. And Richard, would you like to say something?
I was going to just ask a question on the related topic. So you indicate that you've only been able to do 9 team inspections out of 40 in that time period. And I realize, of course, that's because of the COVID-19. And have you been able to catch up? I mean, obviously, the team inspections, which would be in special areas, are hugely important to be undertaken. And I just was curious whether you've been able to fill in for the reality that your intentions for this inspection program have been, to some extent, limited as a result of the COVID-19 situation.
Thank you for the question. So due to COVID-19 pandemic, the team inspection was a little bit delayed, but within 2 years, team inspection will be completed. So am I correct? Mm-hmm.
Did you say 2 years?
Within 2 years.
Within 2 years. That seems like a long time to catch up.
Uh-huh. Oh. Mm. そうね。ただ元々のプランがそんなもんじゃないか。まあそうです。倍ぐらいに伸びて。Well, I can say it's one of the important impact due to the COVID-19, and we had the problem for the travel of the team to the site, and we need to in some cases we need to they need to spend the 2 weeks in the hotel room before entering the site. So those kind of the constraint due to the constraint, we have only 9 inspections out of the 40 as planned. But we still have difficulties due to the pandemic, but the situation is getting better than the worst stage. But now in these weeks, we have increased number of the cases. So maybe we try to finish it within the 2 years, but it highly depends on the situation of the cases we are going to have due to the COVID-19. Any?
I appreciate the challenge. We, of course, have the same challenge in the United States. It's just that some of these team inspections might be quite important, and there may be some prioritization that you need to make to at least have some of the important ones proceed.
Yes, we try to give better or best knowledge, for example, regarding the fire protection to the resident inspector, but there is a limit to not all the resident inspectors are expert on the fire protection. So that's why we have a team in the central office is comprised of the fire expert, and one of the most important concern of the NRA is the fire protection, because in the under new criteria we have lots of enforcement of the and also improvements regarding the fire protection. So it's very important to have a team inspection in each site, and we do understand the importance of the team inspection, but at the same time, we do not want to bring COVID-19 into the site. So, well, we will try. We will just try it. Any other comments or questions? Okay. Wow. We just have only 2 minutes to go, but we have only limited number of the topics today, 2 subjects. But if you have any specific different question or comments on the status of the NLA, please make it. Philip?
Okay. It's not the subject today, but you sent us a paper on continuous improvement of safety. And I thought a lot of things are very interesting and are raising very interesting questions in what is there. I mean, it's not, so I don't know. I'm personally very much interested by the issues that you are mentioning, and I would be ready to discuss about this.
Thank you very much for your comment. And well, regarding the continuous improvement of the safety, we organized a team to discuss this subject, and the team is comprised of not only the NRA staff members, but also the professors, and not only a technical professor, but also the professor in law or those kind. And I can say we have a very interesting discussions, but at the same time, it's quite difficult to explain those things in the different language for us. So please be patient a bit more. And when we produce some sheet of the paper of the summary in Japanese, we'll try to translate it to the English. So I hope within a half year, mid next year, we are going to produce several sheets of the paper regarding our views or team's views on the continuous improvement. So then we'll try to translate it and send it to you. Thank you. Okay.
Fukeda-san, let me just say that I know we're coming to the end of our period. I want to thank you for assembling us this morning, and I didn't want to have us pass without saying how impressed I am, and I'm sure my colleagues are, at the work you've done for the Rokkasho plant and the great efforts you've made to implement the inspection program. There's been a lot of very good work that's been done by the NRA, and I, for one, am very impressed by all you've done and wanted to thank you for discussing it with us this morning.
Thank you. Thank you very much, Richard. So, well, we all appreciate your presence, presence at this meeting, and all your comments and suggestions are quite valuable for our future challenges. So I think we learned a lot from this meeting. So we hope we are going to have a next meeting in Tokyo, face to face. We will have more time, and probably we can have a dinner together. So please stay symptom-free and stay healthy. And I hope we will see you again soon. So thank you very much for joining us this meeting. Thank you. So now goodbye.
Thank you very much. Stay safe.